Hi fellow reefers, I'm Eddie of Eddie's Reef Aquaria. A couple of weeks ago, one of my followers asked me a question and a concern when it came to dosing. And then he said that he was trying to dose fuel on his tank twice a week. And what was happening is that the corals were actually closing up. So I advised him, I'm not there, I don't know what other conditions or situations with the tank are, but I advised him that by my past experience that maybe he was overdosing. So I kind of, I sent that reply, and it left me thinking that I think that I should do a video, a short video, a simple video of what you should actually dose when it comes to liquid dosing, like let's say like fuel or parts A and B, or those different types of liquids that you dose, or minerals, iodine, etc., into your tank. So what is the actual rule of thumb, or what is the actual guidance of actually dosing an aquarium? It doesn't matter what size it is, but it's a rule of thought that I have learned way back. Again, the disclaimer: this is me, what I've actually have done for many years. It works for me. So hold on 1 minute while I adjust the camera and I do a close-up on this little demonstration. Okay, and here's a close-up. So again, like I was saying, you must wondering, why do I have a glass full of water? Here it is, it's full of water, all the way to the rim, to the top, and then I have an egg in the spoon. Okay, what I'm going to demonstrate here is mass. Okay, for argument's sake, let's say that this cup, this glass, is your tank, your aquarium, empty. So like when you get an aquarium, 9 gallons, it's 20 gallons, 40 gallons, 120. This is what they're talking about. They're talking about if you were to fill it up empty, length times width times height, and there's a formula that I used to use before. I forgot the actual number. You divide by a number and you get the actual gallons. Now this is what they're talking about. Now, so this is, let's say that this is 10 gallons. So here's an aquarium, a round shaped aquarium, 10 gallons. Now 10 gallons with nothing. Now for argument's sake, let's say that this egg is mass. Now mass is anything that, let's say that it's going to consume space within another space. Now I don't want to get complicated with physics and all that, but just basic stuff. Okay, so let's say that this egg here that you have is your sand, your corals, fish, and all that you have inside this actual tank. Now watch what happens when I consider this being, again, substrate, rocks, and fish and corals. Watch what happens when I place it inside the supposedly empty tank. Well, as you notice, water has spilled. Why? Well, because now the empty tank that we have here, mass was added. So now the volume of water is not the actual same amount as before. And I'll demonstrate it by taking out carefully, so I don't spill any more water, the egg. Okay, now if you see here, you'll see that the water level has dropped a little bit. So now, what I'm trying to conclude with this experiment is that if, let's say, this tank was 10 gallons empty with air, water all the way to the top, upon adding mass, no longer is it 10 gallons. Now it's a little less. So this is the more or less a simple demonstration. What I wanted to show you when you actually dose a tank, what should you actually dose? So now I'm going to go to my 2 tanks and I'm going to give you a for instance. And just hold on 1 second. Okay, so here's an example. Here we are at my 9 gallon tank. Again, 9 gallon tank would be completely empty. Now once you add the filter down here, well on the side, you add the power head, and you add the substrate and all these corals that you're seeing, this no longer is a 9-gallon nano tank. If I was right now to get like buckets right here and I was to empty all the water, I probably have in water volume, minus all the mass, everything, fish and everything, corals that I have, I might have like between 4, 4.5, and stretching it maybe 5 gallons of water. So what I was trying to demonstrate with the water and the cup and the egg is that when I dose this tank and I go to the instructions of whatever liquid, mineral, whatever I'm adding, I am not going to do the calculations for 9 gallons. I'm actually going to do the calculations for, say, like 4 or 5 gallons, which is the actual water volume that I have here, minus, of course, everything here, the mass. So that's what that would be for me, for my sake, and I've been doing this for many years, 20, 25 years and plus. This is how I dose my reef aquarium, salt water. When I've had fresh water, I go by the water volume. So I wouldn't dose, again, let me repeat what I was saying. I will not dose by 9 gallons as the denominating factor. I would dose, let's say, by 4 or 5 gallons, which is more or less a rough estimate what I think that I have in water volume. And that to me would be the actual measurement that I would use to dose this nano. Now we're going to go to the 40, and basically I'm going to explain the same thing. Hold on one second. Okay, and here we are at the 40. Same thing. But this is more detailed in the sense, as you must know, the Innovative Marine Nouveaux, they're all in one. So not only would you have here what you're noticing in mass, the substrate and the dry rocks, but you also have another catch, the back compartment. So when they say that this tank is 40 gallons, yeah, it's 40 gallons lengthwise, depthwise, not up to here where the dividing wall is, but all the way to the back, and height-wise. So when you get the tank, you say, okay, I have a quote-unquote 40 gallon. I am Nouveau 40. Okay, great. But when you deduct substrate, rocks, and you deduct the wall that's here with the dividers that goes all the way to the back, then you know, the protein skimmer and the heater that I have and the socks and all that, this tank, there's no way it's 40. So for argument's sake, again, like I said before, you don't have to apply physics with application and do all these formulas. You don't have to get that complicated. So roughly, I would say that this tank, from quote-unquote a 40 from front to back, all the way to the back, lengthwise, height and all that, this tank, and you know, protein skimmer and the socks and the heater, and then later I'm going to put the reactor, probably, I'm thinking on GFO and all that, and the ATO that will go here, the part that will go in the water. This tank will probably be maybe from 40, it'll probably go down to, let's say, like 32 or 34 gallons. So again, like the demonstration that I did with the 9 gallon, what I would dose, whatever chemical, liquid, minerals that I would dose here, part A and B, I would use the formula, not using the denominating factor of 40 gallons. But I would use the denominating factor of, let's say, 33 or 34 or 35 gallons. That's what I would actually use to incorporate that number to then so many, you know, cups, quarter of a cup or an ounce or whatever. That's what I would use on this tank, and never would I use the actual 40 to use that as a dominating factor on the formula, because really it's not, it's 40. But when you, again, when you add mass, it's no longer 40. it'll become a 33, a 34, or a 35 gallon. So that's basically what I want to bring up. I hope you found it interesting and educational for those people out there that didn't know about this. If you already knew about it, well, I hope you held on and went along with my explanations. So that's basically it in a nutshell, what this video was all about. I hope you found it informative. If you did like it, hit the thumbs up. And if so, you're welcome to subscribe to my channel. And like I say at the end of all of my videos, happy reefing. Thank you very much. Bye-bye.